All right, here's some more fun examples for chain rule. We're looking at example number 3. And I'd like to do A with you, but then I would like you to pause and I would like you to try B all by yourself. You might notice that A and B look very similar, right? So as we're doing A, make sure you understand how we got all the steps, and then I would like you to try B and then see if you get the right answer. That really will tell you if you're understanding the chain rule and some of these more complicated problems. If you look at example number 3A, I notice that the top is a chain rule, but I also notice that I have a bottom, a denominator, right? So I don't just have chain rule, I also have quotient rule, right? So just like before in the last example, we had product rule with a chain rule in it. Now we have a quotient rule with a chain rule in it. Whew! Here we go. You ready? Let's do our quotient rule. And as we're doing our quotient rule, you will see a chain rule in it. So here we go. Quotient rule says the bottom times the derivative of the top. And remember, as we're doing the derivative of the top, that's using chain rule. That's bringing the 7 down, keeping your inside the same, subtracting 1 from your exponent, and then don't forget to multiply by the derivative of your inside, which is 3. That's the bottom times the derivative of the top, minus the top times the derivative of the bottom. Well, the derivative of x minus 1 is just 1. Don't forget, we have all over our denominator squared. Again, my quotient rule is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So yours should look like mine. All right, so now that we're done with the calculus, it's just a whole bunch of algebra from here that we want to try to combine like terms and factor so that our derivative looks as nice as possible. You might notice in this first term that I have a 7 and a 3. Those are just regular coefficients. I can multiply those together and call that a 21. I also have an x minus 1, and then I have that quantity 3x plus 2 to the 6th power. In my second term, I have just a coefficient of 1 times the quantity 3x plus 2 to the 7th power. All right, this is not quite factored. Do you see that minus sign in between? Because there's that minus sign in between, we can actually try to make this look a little bit nicer so that we just have a whole bunch of factors, multiples, things that are being multiplied together instead of added or subtracted. So, you might notice that in both of these terms, they both have 3x plus 2's in them. The first one has 6, the second one has 7. So we should be able to GCF out, factor out at least 6 of those 3x plus 2's, right? So that's what we're going to do. We're going to try to factor a greatest common factor. Since they both have 3x plus 2's, and the most amount I can take out of both of them would be 6, I'm going to factor out a 3x plus 2 to the 6th power. All right, if I take out a 3x plus 2 to the 6th power, then in my first term, I would have a 21 times an x minus 1. Minus, if I take out a 3x plus 2 to the 6th power, 6 of them, then in my second term, don't I have 1 more left? I have minus a 3x plus 2. You might notice that I have lots of different parentheses, but those parentheses are important because I need to make sure that I distribute the 21 through, and I need to make sure that I distribute the negative through to my 3x plus 2. All right, so here we go. On the numerator, I have my 3x plus 2 to the 6th power. That was my GCF. And then I have all my leftovers, my 21x minus 21 after I distributed it through, and a negative 3x minus 2 after I distributed through my negative. Still over my denominator squared. Don't forget about him. I notice that I have some like terms inside my leftovers parentheses. I have a 21x minus 3x, and I have a negative 21 and a negative 2. So I can say that my final answer for my derivative is a 3x plus 2 to the 6th power times an 18x minus 23 all over that denominator squared. You'll notice that my numerator just has terms that are multiples of factors of each other. So not factors of each other, but they're factors. They're multiplying by each other. And then my denominator is already factored. So later on, when we go to set this equal to 0 or figure out where it doesn't exist, then it's nice and factored for us. I know that was a lot of algebra work, but we're going to have to make sure that we get comfortable doing that for the next chapter. So make sure you practice that. All right, now that we've done A together, because A and B are very similar, I would like you to pause, and I would like you to do example number 3B all by yourself. Following what we did in A, see if you can go all the way through that process and get the correct answer for B. Pause now and try. All right, just like A, we have a quotient rule with a chain rule inside. I'm going to do the bottom times the derivative of the top using my chain rule, minus my top times the derivative of the bottom. Hopefully you got the same numbers I did. Oh, don't forget about your bottom squared. I almost forgot about that. All right, let's combine some like terms. I have a 3 times a 4, or I can say 12, times an x plus 3 times the quantity 4x minus 1 squared, minus my 4x minus 1 cubed, over my denominator squared. I'm going to try to factor out a greatest common factor. I notice that in both of them, they both have at least some 4x minus 1s in common. The most amount I can take out is 2, so I'm going to factor out a 4x minus 1 squared and then leave my leftovers. When I factor out a 4x minus 1 squared, that leaves me with a 12 times an x plus 3 that I need to make sure I distribute the 12 through. When I do, I end up with a 12x plus 36. That's how I got that. And then, when I factor out a 4x minus 1 squared, I have left over another 4x minus 1 in my last term, but there's a negative sign in front of it that I have to make sure I distribute. So that's where I got the negative 4x plus 1 from. Over, still, my denominator squared. I can combine like terms inside my leftovers parentheses, and you should get a final answer for a derivative of 4x minus 1 squared times 8x plus 37 all over the x plus 3 squared. Hopefully you got the same thing I did, and you're on track with doing lots of different derivative rules, possibly all at the same time, with some quotient rule and some chain rule all together.